So which color can observer see, right? So remember this, when the light, right, goes through this prism, what happens is it has to, this angle here, 45-degree angle of incidence, is very important to us. Now the light, right, one of this color, which if this angle turns out to be greater than the critical angle for any of this light, then that ray, that color ray is going to go through total internal reflection, right? So it goes here and then it's going to reflect back down here, rather than going out of the prism. Okay, so which means that if any of these, I don't know yet, but if any of this color, if it goes through total internal reflection, the observer won't be able to see this color. Okay, but then if this angle, right, this angle 45 degrees, if it is smaller than the critical angle for any of this color, then the light will exit outside and it is going to refract, right, bend, and then observer will be able to see that. Okay, so please take a moment to work on this. Take some time to work on this, and then see if you can come up with the explanation or answer for this question. Okay guys, so let us see. So I'm going to erase this part here. Okay, okay, so here, this is not one I want to use. So here, this is the one I did. Oh, okay. So here we are given this information. So let us call, the index of refraction for red light as NR equal to 1.37, N for refractive index for green light NG equal to 1.40, refractive index for violet color NV equal to 1.43. Okay, so they're kind of like increasing order, right? Refractive index for red, green and violet, they are in increasing order, ascending order. So and let's write the NAR equal to just 1. Okay, we are not writing A because that's the standard. Now, as we said, so let's look at, now using, so our job is to see whether this light will exit or not. We are supposed to determine that. To do that, we will be using, Snell's law. Snell's law for refraction, right? Refraction, we have N1, or let's say Ni sine theta I equal to what? Into Nr, okay? I'm going to write N2 or NR is also fine. NR sine theta r. Here remember r means refracted, not reflected. This r has to do with the refraction. R, if r, okay. Alright, so this is our equation. We don't need to call this equation. Now the job is, so we are also given here theta equal to 45 degree, okay. So theta is really theta of incidence, okay, incident angle. We are not talking about this. This is going perpendicular, right, to the prism, so it has to go a straight line. Once it reaches to this interface, it's at 45 degree with respect to the normal. Normal is drawn always perpendicular to the plane, okay. So now, so we have that. So basically we are given this information, right, Ni meaning, you know, refractive index where the light is incident. We are given those are these values here. We are given theta I, incident angle, this is this angle here. NR is where the medium, you know, refractive index of a medium where the light is refracted. This should be in this case air, outside, this would be n equal to 1. Sine theta r, this is the part we don't know. What is this angle? At what angle will this, you know, light refract, okay? So we don't know that. This is what we need to determine. So let's rearrange this equation. And after rearrangement, we can see that sine theta r equal to Ni sine theta I divided by Nr. If I do one more step, then we could write theta r equal to sine inverse of Ni sine theta I divided by Nr. Okay? So let's call this as equation 1 because we are going to be using this multiple times, right? 3 times at least, so we want to refer it back. I'm going to erase this information here, okay? Because I'll need those information. So now, so let's say for red color, for R, red, R means red here, theta R is sine inverse of Ni. What is Ni? Ni is incident, right? Ni is Nr, okay, so that would be 1.37 times sine of 45 degree divided by 1, okay, so really Nr is just n, which is equal to 1. So what value do you guys get here? So I'm not going to write this value out, but I will give you guys a hint about the answer, okay? And if we do for green, theta r would be just like whatever we had. For green we had 1.40 times sine 45 degree divided by 1, right? And then, oh sorry, sine inverse here, don't forget this. If we forget this, it will not work. Okay, so you get theta r for green as some value here. Okay, now for violet, let's call B, right? Theta r is going to be sine inverse of 1.43 times sine 45 degree divided by 1, okay? And then you will not get value, that's the thing. So your calculator may say like error or something like that, okay? Or it will be out of the domain basically. So you will see even from a calculation, you will see you won't get some value there. It is going to come as like error. It's going to go as sine inverse of some value that is out of range. So, in principle, the observer would be able to, like, you know, when we had this light here, right, like this, 45 degree, and the other one was reflected 45 degree. And some of the light went there, observer was able to see. So the light the observer sees is only the red and the green color, because the violet light actually meets the condition for total internal reflection. So the violet color actually goes through the total internal reflection, and the observer here won't be able to see that color. Okay? So please find this answer. You guys find out, but then you should be able to find some number here, and then this one you want to find some value here. Okay? Alright, so that's about for a review. Guys, please do practice some of the problem, Doppler shift and some other problems that we have done, you know, examples we have done in the class, and then if you practice some of the homework problem, you guys will be totally fine in the exam, okay? I will make it not too difficult, but not too easy, in a sense that I want you guys to, you know, see that you guys learned something out of this class. So again, I'll keep you guys in my mind when I prepare the question, okay? I'm not just gonna prepare it randomly. So if you have been doing homework, and if you have been, you know, practicing this example problem and some of the problem we did today, and I think you guys will be in good shape. All right.